Hello, grade 9. So now we're gonna discuss the final exercise for your physics final assessment or the school exam. So let us start our discussion. The first question is actually giving us the picture of measuring a cylinder diameter using a caliper as shown in the picture. And then you need to get what is the result of the measuring or the measurement of the diameter of that tube. Okay, so first we need to know what is the main scale. For the main scale, we can see here. So this zero of the non-use is a stop after 3.2. So the main scale reading is 3.2 centimeter. And then we need to find out the non-use scale by try to find out of this 0 to 10 non-use scale, which one that make a single line with the main scale. So if we take a look here, so it's supposed to be 0, 1, 2, 3, 4, 5, 6. So if we see 6 is actually make a straight line with the main scale. So for the non-use scale, we get the reading is 6, but the 6 must be divided by 100. So we're gonna get 0.06 centimeter. And to get the reading, we need to total all of them. So we get that the total or the measurement result is 3.26 centimeter. So the answer is bravo. Question number 1. Then question number 2. For question number 2, we are given the pictures of a micrometer screw gauge, and then same, the question we need to answer what is the reading. All right, for the reading, we have the main scale as usual, but be careful for the micrometer. As you see here, so this is from 0, 1, 2, 3, 4, 5, right? And then there is also the half part on the under part here. The lower part, we have the half part. So it's mean that half, 1.5, 2.5, 3.5, and so on. Okay, so if we see the reading here, the main scale is actually where the non-use scale is stopped. Where is this part stop, right? So it's supposed to be 5, 6, 7. So the main scale stop at 7. And the 7 is 7 millimeter. As we know that this the result of the micrometer screw gauge reading gonna be in millimeter. And then to get the non-use scale, we need to see again what is the non-use scale that makes straight line with the axis of the main scale. So we see here it's actually at 25. Again, for the non-use scale, we need to divide it with 100. So we're gonna get 0.25 and it's in millimeter. So the reading gonna be the total of them. It's gonna be 7.25 millimeter. So the answer is delta. The question number 2. Okay, question number 3, I think it's quite easy for you. You are given the diagram of the change of state of matter, right? We have a solid, gas, and liquid there. And then the daily event that is the same as the change in the substance for number 5. So number 5 is actually from gas to liquid. So yes, this is actually condensation. Okay, so we need to take a look. Which part from the A to D that's actually condensation? A rose flower in a freezer, so it's actually freezing. Okay, camphor in open air will eventually run out. This because of the evaporation or sublimation. Sublimation from solid to gas, right? And then the outer wall of glass will with the ice get wet. So it's because of the gas outside the glass is actually changed into the liquid. So this is condensation. So the answer is C. And just for checking, heating drinking water until it's boiled, so it's evaporation because the water gonna change into a water vapor. Like question number 3, the answer is C. And next, question number 4. I think it's quite easy, right? The state of matter based on the particle arrangement sequentially from number 1 to 3 is. So as you know that number 1 is a bit tight, but it's not a pack really tight, right? We still have some space here. So this is actually a liquid. And then number 2, you know that they are close to each other. The distance between the particle is very close. And then they are packed regularly, right? So this is actually a solid. And number 3, the particle is really freely moved inside the container. And then the distance between one particles to the other is very far. And of course, the attraction force between them is very weak compared to the solid and liquid. Solid has the attraction force the strongest, right? So this 3 is actually a gas. So from number 1 to 3 is supposed to be liquid, solid, and gas. The answer is C. Okay, the next one, question number 5, right? So here given the diagram of change of state of matter, okay, and I think it's quite easy compared to the other question, right? We need to find out what is P and then what is the process indicated by number 5. So what is this and what is this? Okay. So how we check it? We are given the information that the process from substance R to Q is melting. So if the process is melting, solid is the substance R, because melting is changed from solid to liquid, right? And Q is the liquid. If R solid, Q liquid, so P is the other one. The one that left is only gas. And then for the process number 5, it's actually changed from gas to liquid, so it's condensation. So the answer is gas and condensation. It's B. The next one, question number 6, you are given the Celsius thermometer and X thermometer, and it's used to measure the temperatures of liquid with the result given on the figures, right? We need to find out what is the reading on thermometer X. So what is this? Okay, the important things to get what is the temperatures on X, we need to know that this the upper one is actually the upper fixed point. So this is actually the temperatures of when water is evaporated. And then the next one, we need to know what is the lower fixed point. So this is temperatures when the water is changed into ice or the freezing. So, or the opposite one, the melting one. Okay, so this is the Celsius thermometer and this is the X thermometer. Each of them has the LFP and also UFP. And in order to count it, we actually just need to compare what is the length of this to this, right? With the length of this to this. Okay, but in mathematics, we can write it as, okay, we can write it as a temperature that is shown by C minus the lower fixed point of C over upper fixed point of C minus lower fixed point of C equals to X or the temperature shown by the thermometer X minus LFP of X over UFP or upper fixed point of X minus lower fixed point of X. So now we put the number here. The C is 60 minus the lower fixed point of Celsius is 0. Upper fixed point of Celsius is 100. The lower fixed point of Celsius is 0. And then X is the question, and lower fixed point of X thermometer is 30 degree. Okay, and then the upper fixed point of X is 150 degree. And lower fixed point of X is 30 degree. So from here, we got that 60 over 100 equals to X minus 30 over 120. So we continue our calculation. So we move the 120 to the other side. So 60 over 100 times 120 equals to X minus 30. Be careful with this part. Okay, so keep it as the x minus 30 first. And we're gonna do our favorite things. We don't need to count everything. We just need to cross it. 60 divided by 100, so we can cross the 0 here. And I will also have another 0 there, so I can just cross it. So now on the left side, I have 6 over 1 times 12, or 6 times 12 equals to x minus 30. So 6 times 12 is 72, equals to x plus 30. So x minus 3, sorry. So if we want x alone, so we must send the minus 30 to the other side. So we're going to get x equals to 72 plus 30. So x equals to 102 degree x. So the answer is bravo. Question number 6. Okay. Then question number 7. Number 7 is the same question, but yes, the question is about what is the T shown by the Celsius one. So I think it's really similar with the previous one. We still use the formula that C minus the lower fixed point of C over upper fixed point of C minus lower fixed point of C gonna be equals to X minus lower fixed point of X over upper fixed point of X minus lower fixed point of X. Okay, so we just need to put all the numbers here. The C is not known, right? So we just write C here. That's a question. Now our fixed point of C is 0. Upper fixed point of C is 100 minus lower fixed point is 0. Equals to X is 102 minus the lower fixed point of X is 30 over upper fixed point of X is 150 minus lower fixed point of X is 30. So we get that C minus 0 is C. C over 100 equals to 102 minus 30 is 72 over 120. So we can send 100 to the other side. So it's going to be the multiplication. So 72 over 120 times 100. So C equals to, okay, we do the crossing again. So we have 1 0 here and 1 0 here. And then 72 divided by 12 is, this is 6, this is 1. So we got 6 times 10 divided by 1. So we got 60 degrees Celsius. So the answer is delta. That's question number 7. Next, question number 8. You are given several substances, and then you just need to find out which one that acidic substance. Detergent is a base. Vinegar is, yes, acid. Lemon is, of course, acid. The antacid or the medicine for the forma, right? So this is actually base because it's used to neutralize the acid inside our tummy. And then baking soda is base, and milk is actually acid, even though it's not a strong acid, of course. So the acidic substance is 2, 3, and 6. So the answer is bravo, 2, 3, and 6. Okay, question number 8. Now, question number 9. You are given a pictures of a ball that is thrown vertically, right? And then you are given several statements, and you need to find out among all of that statement which one is the correct one. Okay, we check one by one. Statement 1, the potential energy at position 1, so the PE at 1, is greater than the position of 2. Of course, no, because position 2 has a higher position. And when we're talking about the potential energy, it's actually mass times gravity times h. So the one that has that's higher gonna have a bigger PE, right? So this one wrong. And then the smallest kinetic energy at position 2, yes, it's correct, because here PE is maximum. And when PE is maximum, so the KE is equals to 0. Okay, and then the kinetic energy at position 3 is greater than position 1. The kinetic energy is actually getting bigger and bigger when it's going downward. Why? Because the kinetic energy is depends on how mass and then speed square. And as you know that it's actually accelerated. When it's accelerated, it means when at position 1, the velocity gonna be bigger, and so does the KE or kinetic energy at position 1 also gonna be bigger. So this is wrong. Then, when move from position 2 to 3, the potential energy is decreased. Yeah, sure, because the potential energy is converted into kinetic energy. And then when moves from position 2 to 3, the kinetic energy is decreased. No, the kinetic energy is actually increased because the potential energy is actually changed into the kinetic energy. Okay, so the answer is okay, 2 and 4. So it's B. That's question number 9. Okay, then question number 10. There is a durian tree, all right? Amongst you like durian? Okay, so the durian is 2 kilograms. So the mass is 2 kilograms. And it's really fall from 4 meters above the ground. So it was here at the beginning. And if the Earth gravitational acceleration is given 10 meters per second square, and then the kinetic energy of the durian at height of 3 meters from the ground is. So what is the kinetic energy at this position? So I will name these two as the two different positions. This is the position 1, and this is the position 2 when the durian is 3 meters above the ground. So we know that when it's still at the top of the tree, so the durian is actually only have the PE, right? So the mechanical energy is only PE since the KE is equal to 0, right? So MA equals to PE. This is at position 1, so I will give index 1 for every of this. So the MA at position 1 is actually the mass times gravity times the H1. And which one is the H1? H1 is the height of the first time. So this is the 4 meter. So it's 2 times the gravity is 10 times the H is 4. So the ME1 is actually equals to 2 times 10 times 4. So it's 80 joule. And then the things that we need to know that the ME is always same wherever is it. So does the ME at position 1 will be equals to the ME at position 2. So it's mean the 80 joule gonna be equals to PE at position 1 plus the KE at position 2. Sorry, 80 joule gonna be equals to P at position 2, and so does plus KE at position 2. So now the question is the KE at position 2, right? This is the question. So we need to continue. 80 equals to PE at position 2. So mass times gravity times H2. H2 is the 3 meters here. Okay, so the mass is 2 kilogram times gravity is 10 times the H is 3 meter. So it's going to be 60. This is for the PE2. And it still equals to KE2. So from this equation, I think you can answer it. What is the KE, right? So KE2 going to be equals to 80 minus 60 or 20 joule. The answer is A. There's actually a shortcut to solve this kind of problem, right? So you just need to find what is the change in the change in the height, right? Because we know that the change in the height is actually will tell us the change in the PE, and the change on the PE gonna convert into KE. So we just need to find out mg delta H. We also can use this to get the KE at position 2. You're going to get the same answer if you use this way. So going to be 2 times 10 times the delta H is just 1. So this is going to be the KE2 or just 20 joule. But if you're not sure about this, you can just use the conventional one, right? But I think it's easier. You don't need to memorize the new things, right? Okay, so now number 11. You are given the arrangement of the solar system, and then you need to find out what is the planet that actually have the characteristic as shown on the above, right? On above. So it has no natural satellites. Okay, there are many that don't have a natural satellite, right? But of course, there's something before Earth, right? The one that doesn't have a satellite. And then knowing as of morning stars, I think you can guess it now. And it is the hottest planet because its atmosphere composition of carbon dioxide gas has a direction of a rotation opposite to the direction of rotation of the other planets. Or we call it as a retrograde, right? I think you can find out. So this is actually the properties or the characteristics of Venus. And Venus is the planet that stayed by the number 2. So here's the Venus. Mercury, Venus, Earth, Mars, and so on. So the answer is 2. That's question number 11. Now question number 12. You are given the graph, right? And you need to find out what is the track of the object according to the graph. So as you know that this is a 0, and then there are 3 interval of time. In the first interval, its velocity or its speed is actually getting higher or getting bigger. So it's mean at this point it's actually being accelerated. And then this part, the second part, is actually move with a constant speed, so that okay, the velocity is always same all the time until this point, so it's decreased. So when the velocity decrease, so it means the object is being decelerated. Okay, so we need to find out uh, the object motion on the option here. This will be accelerated, okay, and then constant speed, and decelerated. We call it as UAMSL, uniform accelerated motion in straight line. And here is UMSL, uniform motion in a straight line, and UDMSL, uniform decelerated motion in a straight line. Okay, so we check. If it's going down, it's being accelerated, yes, and then move in a what do you call it? In a plane, in this is a plane, so it's actually constant, right? Or in a flat surface, so it's gonna be constant. And then it's decelerated, usually the decelerated one is actually if it's going up, right? This is actually gonna be accelerated again, so it's wrong. That's not the option. Let us check B. Okay, the one that accelerated is yeah, the moist ball is moving down, so this is accelerated, constant, and going up decelerated. So the answer is Bravo. If this one, it's decelerated, constant, and then decelerated. If this one, constant, decelerated, constant. Now number 13. There is a man possesses a cart containing 10 identical blocks, right? Each block has a mass of 5 kilograms, and then the cart acceleration is 1 meter per second square. If the 2 blocks are taken off from the cart, and then we need to find out what is the acceleration. Okay, so in this case, there are 2 conditions. The first condition, the mass is the 10 times 5 kilograms, because it say there is 10 identical blocks, right? So this is 50 kilogram, and then it will experience the acceleration is 1 meter per second square. So this is everything in condition 1. In the second condition, the mass gonna be reduced because 2 of the block is taken. So now we only have 8 blocks, right? 8 blocks times 5 kilograms, so it's 40 kilogram. And then the question, what is the acceleration on this condition? To solve it, we need to have the information about the force. It's not given here. So we can assume that the force in the first and the second condition is actually are the same. So we just name it as F. So we can say that F1 equals to F2. So we assume that the man is not changed the force that he is given to the cart, right? So in the first condition, F is counted as M1 times A1. And in the second condition, F is counted as M2 times A2. And we know that M1 is 50 kilogram times the A1 is 1 equals to M2 is 40 kilogram times the A2 is A2. That's the question, right? So we got 50 times 1 is 50 equals to 40 times A2. So A2 gonna be equals to 50 over 40. So A2 equals to 1.25 meter per second square. It makes sense when the mass is reduced and then the acceleration is getting bigger. So the answer is D, 1.25 meter per second square. Question number 13. Then question number 14. Okay, you are given the lever, okay, and then you need to find out what is the force required for balancing the system. So actually in the balance system, we can know that W over F is equals to LF over LW, or we also can write as LW times W equals to LF times F. So actually that's the same thing, right? The important things when we're talking about it is actually, yes, we have the weight is 100 Newton, and I was the question, and this 30 centimeter is actually distance from weight to the fulcrum. So this is the LW. But be careful with the 70 cm there. 70 cm is actually the distance from the weight to the force, right? But if we want to get the LF or the force arm, we need to count it from force or the point when we will apply the force to the fulcrum. So only this one. This is going to be the LF. So LF going to be 70 minus 30. So it's 40 cm. We got it from 70 minus 30. Because LF always counted from fulcrum to F. So LF is from fulcrum to F. And then for the LW, it's actually distance from fulcrum to the weight. Okay, we continue our calculation here. So the weight arm is 30 centimeter. The good things about this kind of question, as long as both of them are having the same unit, we are not compulsory to change the unit into meter, right? So we can just write it as 30 cm times the weight is 100 Newton, gonna be equals to our F is 40 cm times F. So we're gonna, sorry, it's 40. So we're gonna get the answer here. So F itself is just move 40 to the other side. So 30 cm times 100 Newton over 40 cm. As you know, this is the reason why we don't need to change the unit, because we're going to cross the cm here with this one, and 0 with 0. And then, yeah, 3 times 100 is 300 over 4 Newton. So this is F. So F equals to 75 Newton. So the answer is C. That's question number 14. Okay. Then the next question, you are given the position of the object inside the liquid, right? You need to find out the smallest hydrostatic pressure experienced by the object, that is indicated by which number. So we know that the hydrostatic pressure is actually counted as rho, or the density of the liquid, times G times H. But remember, the H is actually the depth of water, or maybe a liquid, all right? So for 2, the H is 0, and then 1 is this long, and then 3 is this long, and then 4 is this long. This is the H. So for the hydrostatic pressure, actually depends on the height of the water that's going to influence the pressures that will be experienced. The higher the surface, right? So the bigger the pressure. So it has pH bigger than the pH here, because the H is longer as well. Okay. So to find out the smallest hydrostatic pressure is the one that has the smallest H, or the shallow one, right? So the shallow one is P. It's not even shallow. Yeah, it's actually just floating. So the H is 0. That's number 15. Then number 16. Okay, I hope you still remember this topic. It's about resonance. The resonance occurs when the tuning fork can produce sound with a frequency of 350 Hz. Is tapped against the end of the end of an organ pipe as shown below, right? And then the speed of sound is given, and we need to count what is the height of the air column or h. So from this question, we know that the frequency is 350 Hertz, and then the speed is 350 meter per second. So to get the h, we need the information of lambda or the wavelength, because h is actually counted as 2n minus 1 over 4 times lambda. So n is actually the order of the resonance. Okay, so n is actually order of resonance. So start from 1, 0, and so on. We also can know that actually the resonance only happen when is actually the height of the air column is 1/4, 3/4, 5/4, 7/4, and so on. Okay, so because this is say the first resonance, so the order of the resonance is 1, so n equals to 1. So we can add it here, n equals to 1 because of first resonance. If it's not mentioned in the question, if let's say the question doesn't mention about this is first, second, or third, you can just assume that's actually the first resonance. Okay, so because this is the first resonance, so h gonna be equals to 2 times 1 minus 1 over 4, right? Times the lambda. We don't know the lambda, so we need to count it first. We can use this information to count lambda. We know that v is actually equals to lambda times f. V is 350 meter per second. Lambda, we don't know it. And then the frequency is 350 Hertz. So we can get that lambda equals to 350 over 350. So lambda equals to 1 meter. So we just count it here. 2 times 1 is 2 minus 1, 1. 1 over 4 times 1 meter. So the h is actually 1/4 meter, or in centimeter, we're going to have it 25 centimeter. Because from meter to cm, we need to count it by 100. So the answer is A, 25 centimeters. Question number 16. Next, question number 17. On this question number 17, a tuning fork with a frequency of 550. So this is actually the similar question. The F is given 550 Hertz. Vibrated above the tube filled with water, which level can be changed, right? So the level of the water can be changed on that tube. In this event, the third resonance, okay, this is very important, the third resonance, so it's when it will give us the information n equals to 3. Occurs when the air column height is 75 centimeters. So the air column height is mean h is 75 centimeters. The speed of the sound in that place is, okay, the question is asking what is phi. So to answer it, we need to remember that phi is counted as lambda times f, right? We know the f, 550 Hertz, but we don't know the lambda. How we get the lambda? We use the resonance formula, resonance equation. So h equals to 2n minus 1 over 4 times lambda. H is here is 75 cm equals to 2 times, okay, it's saying the third resonance, so 2 times 3 minus 1. Be careful with this, over 4 times lambda. So we're gonna get 2 times 3 is 6. 6 minus 1 is 5. So 5 over 4 times lambda equals to 75 cm. So to get the lambda, we move the 5 over 4 to the other side. 4 move there, so it's gonna be 75 times 4 over 5 cm is gonna be equal to lambda. So lambda equals to this one is divided by 5, right? So it's gonna be 15. So 15 times 4 is 60, right? Yeah. So 60 cm is equals to lambda. Okay, we know the lambda, so we can continue our calculation here. V is counted as lambda times f, but be careful here because the answer in meter per second, right? All of them are meter per second, so we need to change this lambda into meter. So the lambda equals to 60 cm or it's equal to 0.6 meter. I hope you still remember that change from centimeter to meter is mean divided by 100. So the lambda is 0.6 meter times f is 550. So 0.6 times 560, so 550. If you don't like this calculation, you can just make it 6 times 55, right? So it's going to be 330 meter per second. So the answer is Bravo. Like question number 17. Okay, then the next one. Question number 18. There is an object located 30 centimeter in front of the concave mirror as shown below. And then where the image will be formed? Okay, we know from this information, the object located 30 centimeters. So we know the distance of O or SO equals to 30 cm. And then from the pictures, we can see that F is here 10 centimeter. So F equals to 10 centimeter. So this is actually a half of the radius of the concave mirror. And you know that when we're talking about concave mirror is the positive mirror, right? So when it's a positive mirror, so the F gonna be positive. And yes, the question asking where will be the SI. So this is the question and how we answer it. We're gonna use the equation of a mirror, 1 over SO plus 1 over SI equals to 1 over F. Okay, 1 over 30 plus 1 over SI equals to 1 over 10. Here, remember, this is concave mirror, the F is positive. So 1 over 30 plus 1 over SI equals to 1 over 10. So if we want to have 1 over SI alone, so we send 1 over 30 to the other side. Okay, we make them to have same the bottom part. So it's going to be 30 and this is 3 minus 1 over 30. So this is 1 over SI and 1 over SI equals to 2 over 30, right? In order to get SI, so we need to switch that. So 30 over 2. So SI is going to be equals to 15 centimeter. As you see here, the SI is not positive, it's not negative, right? So when the SI is positive, so it's mean real image, or when we're talking about mirror, so it's mean in front of the mirror. Okay, so the answer is 15 centimeter and in front of the mirror. The answer is A. Next one. Okay, the next one, there is an object placed 3 centimeter in front of a concave mirror that has a focal length 4 centimeter, right? Okay, so from this question, we get the SO equals to 3 cm. And then again, it's a concave mirror. When we're talking about concave mirror, the F is positive, the F is 4 cm, it's positive. And the properties of the image formed by the mirror are, actually, you can use your knowledge if you have memorized about it. So for this question, the object is actually somewhere smaller than, located somewhere closer than the focal point, right? So there is special things about it if you still remember. But if you forgot, you actually can just sketch the possible image, right? So let's say this is the F 4 cm, right? So the object is somewhere here, right? The 3 cm. So if we draw the image, it's gonna be from here to here, right? Okay, then from here to here to F here. So if you see that they are not gonna meet somewhere, okay, they're not gonna meet somewhere. So we can say that we're gonna have a virtual image, right? And then you can sketch back because they are not meet somewhere here. So we can extend the reflected ray. So this is the reflected ray, we extend it to the back. And then this is the reflected ray, right? We can, okay, wait. We can extend it to the back as well, right? So it's gonna meet somewhere here. So the image gonna be bigger, virtual, upright, and then magnified. If you don't know as well, you don't remember how to draw, and you are worried that your drawing probably not neat enough, so you cannot find the image, you also can use a calculation. 1 over SO plus 1 over SI equals to 1 over F. So SO is 3, 1 over 3 plus 1 over SI equals to 1 over 4. So 1 over SI equals to 1 over 4 minus 1 over 3. So this is 12, this is 3, this is 4 over 12. So we're going to get 1 over SI is equals to minus 1 over 12. So we got here the SI is minus 12 centimeter. When SI is negative, so it's mean virtual image. And usually if we have a virtual image, it's always upright. Okay, so virtual upright. And then how we know it's magnified? You know that SI is bigger than SO because SI is 12 and then SO is 3, right? So when SI is bigger than SO, so it's going to be magnified. Okay, you can use any ways that you think easier for you to be memorized. Okay, so virtual, upright, and magnified, then the properties of the image and question number 19. The next one, question number 20. You are given the pictures there. And then from the figure, you need to find out what is the type of the eye defect. And then the type of lens needed to see the distance object clearly. So it's come before the retina. So it's actually the minus one or the myopia. Yeah, the myopia, if we're talking about the myopia, is we call it as a negative one because it's half by the negative lens. And the negative lens is concave lens. So the answer is myopia and concave lens. So the eye defect is myopia and it's helped by the concave lens. The question number 20. Next, question number 21. Further, closest reading distance without using eyeglasses is 50 centimeter. So this is the punctum proximal of father is 50 centimeters. So it's say that he's wearing a glasses. So this is actually the PP of the hypermetropia. And the father wants to read the distance 25 cm. So this is the PP of the normal people. The punctum proximum is 25 cm. What is the correct eye glaze insert to glasses lens to have the father vision? So you need to find what is the power, the lens, and also the power. All right. So we can count it. Actually, when this condition happen, we expect that the father will put the newspaper or the reading materials in a normal distance. So it's been 25 cm. And then because his eyes can see on the 50 centimeter, so the glasses will have to make the image on the 50 centimeter. So here, where we put the object, right, is at 25 cm, but the image by glasses will be somewhere 50 cm so that the father can read that. So this 25 cm or the PP of normal gonna be where we put the object, and then here where the image is gonna be created. And for glasses, always create virtual image. So we got the equation 1 over SO plus 1 over SI equals to 1 over F. Again, the SO is the punctum proximum of normal, 25. And then because it's virtual, so it's going to be negative. 1 over 50 going to be equals to 1 over F. So we count it. We make it same. 2 over 50 minus 1 over 50 equals to 1 over F. So 1 over F is going to be equals to 1 over 50. It's positive, right? So F is actually positive 50 cm. But the question is asking what is our length of the lens that he used, right? So P equals to 100 over F, but F must be in cm. So we're going to count it 100 over 50. So it's 2 and it's positive. So it's positive 2 diopter. Okay, just a reminder for you, for the hypermetropia, always have a positive lens and the focal length is positive. Okay, next question number 22. There is the interaction between two charges shown there. Okay, there's Q1 and Q2. and they repel to each other because they are the same charges, and the force acting is 360 Newton. So we know that F is 360 Newton. And then for the distance, it say that 10 centimeter, or we can say 0.1 meter. And we need to find out what is the magnitude of each charges. So the question asking what is Q1, that's actually equals to Q2. Of course, we always know the K, yeah, in case it's not mentioned on your exam, if it's appeared. So just remember that K is actually 9 times 10 to the power of 9 Newton meter square over C square. And how we count it, how we got the Q, we know that F equals to K, Q1, Q2 over R square. So F here is 360 equals to Q is 9 times 10 to the power of 9 times Q1 times Q2. And they are same, so we can just name it as Q times Q over R square. R square is mean that 0.1 square. Okay, so 360 times 9 times equals to 9 times 10 to the power of 9 times Q square over 0.1 square. So we can make it into 0.1 times 0.1 or 0.01, right? Okay, so we times the 360 with 0.01 equals to 9 times 10 to the power of 9 times Q square. So we got it 3.6 equals to 9 times 10 to the power of 9 times Q2, Q square. So we can move the 9 times 10 to the power of 9 to the other side. So we get 3.6 divided by 9 times 10 to the power of 9 equals to Q square. So here we got 0.4 times 10 to the power of minus 9, because I hope you remember when you have 1 over a to the power of x equals to a to the power of minus x, right? So this is Q2, or Q square. Okay, so 0.4 times 10 to the power of minus 9 is actually same with 4 times 10 to the power of minus 10, right? So this is Q square. So Q is actually the square root of 4 times 10 to the power of minus 10. Okay, so Q equals to square root of 4 times square root of 10 to the power of minus 10. Square root of 4 is 2. And how we cut this square root of 10 to the power of minus 10? If you know that square, let's say we have square root of a, so it's actually a to the power of half, right? So it's actually times 10 to the power of minus 10 times half. Okay, so we got that 2 times 10 to the power of minus 5. Okay, so the answer will be in micro, so you must make it into 10 to the power of minus 6. So if it 10 to the power of minus 6, we're going to have 20 here, coulomb. So the Q equals to 20 microcoulomb. So the answer is E, 20 microcoulomb. Okay, that's question number 22. Next, question number 23. You are given the pictures of a circuit. Based on the figure above, the electric current flowing through the 12 ohm or resistor or I2 is. So if you have this kind of question, you need to simplify one by one. The first thing that can be simplified is this part, right? So we can simplify that into RP, right? So this is the RP. So we can count RP as 1 over RP equals to 1 over R2 plus 1 over R3. So we're going to get 1 over RP equals to 1 over 12 plus 1 over 4. So we're going to get 1 over 12 plus 3 over 12 going to be equals to 1 over RP. And 1 over RP equals to 4 over 12. And RP equals to 12 over 3 over 4 or 3 ohm. So we got that Rp is equal 3 ohm. After we got Rp is 3 ohm, we can simplify this circuit into, okay, there is the R1, there is 3 ohm, and then there is the Rp right here, 3 ohm. And then the last one, we have the R4, 6 ohm. And then they are connected to the V12 volt. Okay. After this, we need to know the I or I1. Why? Because we need to find out what is the V across this section, the BC section, right? So we need to simplify this again. We know that all of them are series, so we're gonna get the RS. So RS here is R1 plus R2, Rp plus R4. So we're gonna get 3 plus 3 plus 6 or 12 ohm. This is the RS. So after that, we can simplify that equation become, all right, the only one R and then the V 12 volt, and then this is the RS or R total, that is 12 volt. Using this information, we can count what is the I here, the I that comes out from the battery or I1. Okay, so we use the Ohm's law, VIR, right? VIR equals to I times R. The V here is 12, and then I is the question, and then R is 12, right? The R here is the R total. So the I1 is, the I here is I1. So the I1 is equals to 12 divided by 12 is 1 ampere. So this is 1 ampere. This is also 1 ampere. So we also can put here it's 1 ampere. The question is I2, right? So to get I2, we need to know what is the V across BC. The V across BC. Same with this one and this one. So to get the V across BC, okay, V across BC, we count it using the information of here of I. So V across BC equals to I times R. The I here is I1, the R is the Rp, because across BC we have Rp, right? So 1 times 3 ohm. So it's equals to 3 volt. This is V across BC. When we're talking about V across BC, and we back to this picture, V cross BC gonna be equals to V across R2, gonna be equals to V across R3. So in order to get what is the I2, I2 is the one that passed through the R2, right? So we're gonna use V at R2. V at R2 is actually I2, sorry, I2 times R2. So I2 is the question, VR2 is same with the V across BC, so it's 3 volt equals to 3 times the R2 is 12. Okay, so I2 is 3 over 12 or 1/4 or 0.25 ampere. So the I2 is 0.25 ampere or D. That question number 23. The next one, question number 24, is a bit easier compared to the previous one. Sorry. Okay, you just need to find what is the potential difference across BC. So the question asking PBC. What is this? Okay. So V across BC, same with the V across R1 here. But before that, we need to simplify this equation. And as you know that I that will be passed through R1 is the I, right? So we need to get what is the I. To get the I, we need to simplify this R2 and R3 first, right? These two are parallel, so we're going to get RP. So 1 over Rp equals to 1 over R2 plus 1 over R3. So it's 1 over 20 plus 1 over 80. This equals to 4 over 80 plus 1 over 80. So 1 over Rp equals to 5 over 80. So Rp equals to 80 over 5 or Rp equals to 16 ohm. So we can simplify the pictures, become like this. This is the Rp. The RP is 16 ohm, right? 16 ohm with the R1. The R1 is here. It's 4 ohm. And this is the V94. So using this picture, we can count what is the RS, right? The RS, or this is actually the R total. So R total equals to RS equals to RP plus R1. So 16 plus 4. So the R total equals to 20 ohm. So using this information, we can count what is the I. Since V equals to I times R, V equals to I times the R total. V here is 9, I is the question, and then R is 20, right? So I equals to 9 over 20 or for 0.45, right? 0.45 ampere. So that's I. And after you got I is the one with that pass through the R1, right? So after you got I, you can count what is V across BC or V across R1. So V across BC equals to V across R1. So we can count it as you see on this picture. Is it actually I times the R1? So I is 0.45 times R1 is 4. So it's going to be 0.45 times 4 is 0.9. So 1.8, 1.84. The answer is A. Oops. Yeah, the answer is A, 1.84. Okay, that's question number 24. The next one, question number 25. You are given some the electric instruments, and then you need to find the electric device that work based on Lorentz force. The one that use Lorentz force is actually the one that has a motor on it, right? So electric fan, galvanometer, yes. Electric bell is used the electromagnetic, not the Lorentz force. Transformator is actually used to Faraday, not the Lorentz force. So the answer is 2 and 4. That's D. Okay. Then number 26. You need to find out the diagram that's actually following the Lorentz force. Okay, you can use your right hand, right? Your right hand. All of the 3 fingers, the middle fingers to your little fingers will be perpendicular with your 4 fingers, and also it will be perpendicular with your thumbs, right? All of them are perpendiculars, and then it's must following the direction of F, B, and I. Okay, so if this is your thumb, it's actually telling us the direction of I, and then your 4 finger is actually telling you the direction of B, and then the other 3 fingers, this actually will move here. Oh, sorry, so bad. Okay, all right, so these 3 fingers actually telling us the direction of the I. Oh, sorry, the F, the Lorentz force. Okay, if across, so it's mean that away from us, away from observer. And if it's dot, so it's mean toward observer. Yeah, if we check A, the F is going up, right? The B is going there, so I is counting 2. Yes, this is correct. For this one's wrong because it's F is going there to the left, and then B is toward the paper, so I must be going up. And then for this one, B, if B is going down, I must go to us, so I must be going there. That's wrong as well. And then for D, if F is to the right and then B is there, F is to the right, and then B is to there, so I must be going down. That's wrong. So the correct one is A. That's number 26. The next one, question number 27. Okay, you are given a transformer. Okay, and then this transformer has data, and then you need to find out the step down transformer. So when we're talking about step up and step down transformer, I hope you remember this requirement for the step up one and for the step down. For the step up, V in the secondary or output gonna be bigger than VP. And then so just for the NS gonna be bigger than NP. But for I is the opposite one. IS gonna be smaller than IP. And a step down, so it's mean the output gonna be smaller than the input of VP. And so does NS gonna be smaller than NP. And then for the I is the opposite. So IS is bigger than IP. So we check here based on the number of turns, the one that step down, so it's mean that the NS is actually smaller than NP. So this one wrong, this one correct, this one wrong, and this one correct. Okay. Oh, we got the answer already. But we check the IP, yeah, guys, IP and IS. So the step down say that IS is bigger than IP. So we check here IS bigger, IS bigger. Okay, so the answer is 2 and 4. So that's D. D, 2, and 4. Question number 27. The next one, there is question number 28. Read the following statement, right? Factors that determine the amount of induced EMF is actually based on the Faraday's experiment. So the Faraday experiment is like when you have this coil and then you try to make the magnet move out and into the coil, right? If you move it faster, so of course the induced electricity will be bigger. And then if you change the magnet's polarity, so it means the direction of the current also will change or the opposite one. Usually we check it using a galvanometer. Okay, so this galvanometer has a needles that can go to the right and also go to the left, right? So now let us check. The one that influenced the amount of the induced EMF, the number of turns that conducting the wire, yes. The more turns will be, the more electricity will be generated. The size of the magnet, no. The diameter of the wire, no. The strength of the magnetic field, yes. If the magnet is stronger, so the induced EMF also will be bigger. The relative speed, yes. The relative speed is actually how fast you move it. The faster you move it, the bigger the induced EMF that will be produced. The position, no. It's actually just affect the polarity, not affect the direction of the current, not the peaks or what do you call it, the magnitudes of the induced EMF that will be produced. So the answer is 1, 4, and 5. That's A. Okay, 2 more numbers. So this is the SI question. Whenever you have this kind of question, actually it's not too hard, right? Just remember when there is a change in temperatures, you're gonna count Q as M C delta T. Okay, M is mass, C is the specific heat. And then delta T is actually change in temperature. This is only happen when the temperature change. But when the temperature is not changed, Q always counted as M times L. L is the latent heat. It's depend on the process, right? Is it just the latent heat of melting or evaporation? Okay, so now we check here. The question asking calculate the amount of heat required for the process from P to R. So P to R. So only this process, P to Q and then Q to R. We know that from P to Q, it's actually change the temperature, right? From -5 to 0. So for total Q, we call it as a Q from P to Q plus Q from Q to R, right? There are two Q here. Q from P to Q is actually the change in temperature. So we call it as MC times delta T. And then from Q to R, this is actually, there's no change in temperature, right? So it's mean the change instead of meter, so M times L. And the process here, because it's about ice, water, right? So it's mean this is the 0 degree, right? This is the melting point. So this is the latent heat of melting. Okay, now we count it up. Sorry. We must remember as well that P is actually ice and then Q is also actually ice. So the C that gonna be used here is actually the C of ice. Be careful with that because this is ice and then it's melt and then here is changed to be water. Okay, so the mass of the things here, the mass is given 400 grams, right? So mass equals to 400 grams or equals to 0.4 kilograms. So we just need to put it here, 0.4 times the C of ice is 2,100 times the delta T here from -5 to 0. So yeah, you can just count 0 minus -5, right? Okay, and then plus the mass is 0.4 again times the latent heat of melting is 336,000. Okay, so we count it 0.4 times 2,100 times 5 plus 0.4 times 336,000. Okay, we count it now. 0.4 times 2,100 times 5. Okay, I don't like this number. So I count 0.4 with 5. I got 2 times 2,100. Okay, plus this one. So this is 4 times 33600. Okay, 4,200 plus this one, 0, 0, 24, 2, 12, 14, 1. This one. So it's gonna be equals to 0.06813. If I'm not mistaken. Right, 4,200. Yeah, 1386. Yeah. Okay, so the answer is 138,600 joule. So Q total is 138,600 joule. Please be careful. Take a look on what is the process given there. Okay, and so that's when you have this kind of chart or this kind of diagram, please make sure that you read what is on the axis. In this case, the axis is telling us about the time, but sometimes they also give us the question, some of the heat graph usually also have, this is actually the Q and this is actually the temperature. So be careful if it's Q is in a joule. So let's say the process is 0 and then this is 100 joule and then this is 300 joule. So it's telling us about the energy, right? It's actually telling us what is the heat on that process. So be careful, read the axis of that question. Then number 30, I think it's quite easy for you. You are given the transverse wave, and then from the diagram, you need to determine the frequency of the wave, right? So question asking for what is the frequency, for B, what is the wavelength, and then C is what is the speed. So this is the question. Okay, on this question, we know that the time is 0.5. From here, we know that time is 0.5. And then for this 0.5 second, we have 1, 2.5, right? So the N is 2 and 2.5 waves. Okay, because one transverse wave is actually one crest and one through. Okay. Okay, so now for the 30 centimeter, the 30 centimeter is the S is 30 centimeter, and we know the number of wave is one and then half, right? So just 1.5 waves. And what is this number? Right. This number is actually telling us the distance from the equilibrium position or the undisturbed position. So it's actually telling us about the amplitude. Okay, that's amplitude. And now how we count the frequency, the wavelength, and then the speed, right? So here the answer. So the frequency is counted as the number of wave in a unit of time, right? So we can use the information here. The n is 2.5 and then the time is 0.5. So for the frequency is 5 hertz or 5 per second. And then for B asking for lambda, right? Lambda is what is the length in for one wave, right? So S over N is 30 over 1.5. So it's mean 20 centimeter. That's lambda or 0.2 meter. Actually, we also can use your logic, right? Here, you also can use your logic. This is 30 centimeter and there are three division, right? 1, 2, 3. And then for one lambda is this one. So if each of them is 10 centimeter, so lambda is 20 centimeter. You can use that logic as well. Then now we back to the question. C asking for the speed, right? Okay, C asking for the speed. V equals to lambda times F. So it's 5 times 0.2. So 5 times 0.2 is, yeah, it's 1, right? 1 meter per second. So that's the question, the answer. Yeah, I think that's all for the discussion of the final exercise for your final school examination. I hope that you prepare everything well. Uh, get enough rest, eat well as well, right? And good luck, and God bless you for your upcoming exam.